Hopefully you can hear me. Hi. My name's Dr. Zaki Hussein, and I'm the CEO and founder of Touchlab. And the question I'd like to answer, I'll just repeat it, is how would the world look if robots had a sense of touch? And I want to start this with a picture of a number of robots, as you can see here, a number of different robots. These were all part of something called the ANA Avatar X Prize, which was a 4-year competition to transport human presence to any location, any time, which we participated in and became a finalist team. So what has it looked like until recently with robots? I don't want to be do too much kind of scaremongering, but I'll give you a couple headlines. Well, last year, we had news of, for example, factory workers in Korea being crushed by a robot, crushed to death, unfortunately, because they were mistaken for a box of vegetables. Closer to home, there's Ocado, who had a whole warehouse burned down. I think this was between 3 and 5 years ago because there was a robot collision, mysterious. But I think this was a very, very costly issue. Thankfully, no deaths. Recently, a Tesla worker being pinned to the wall by a robot. Again, unfortunate accident. And this is even before Skynet, guys. I mean, seriously. In more positive news, a famous Japanese robot called the Robear, which was designed because Japan has the most aged population in the world. This is a very strong robot. It can carry entire patients and reduce the workload of nurses. However, you'll realize that if you watch videos, it's very, very slow, and it doesn't have any hands or fingers. So it really is quite limited in what it can do compared to a normal nurse. So what I'm trying to drive home here is that robots without skin are clumsy. And obviously that means they're also dangerous if they're strong and powerful and fast. So skin is the largest organ in the human body. It's a vital organ. And almost every organism has some form of mechanical sensing ability, even individual cells in your body or amoebas. Currently, robots have grippers that don't accurately relay tactile information. And there's a lot of workarounds being used. For example, we're putting cameras into fingertips, things like this, but then you have to replace the whole fingertip. There isn't anything as thin as human skin and as compliant. And here you can see human skin. In the dermis layer, we have four mechanoreceptors. These are the mechanical sensors in skin that have been very hard to kind of replicate in a similar way in a robot. I won't name too many of these. They have funny names like Ruffini's corpuscule, but they're responsible for sensing forces and pressures and relaying that to you. And this means that they give you basically the sense of pain, texture, hardness, even slip detection. And this is what we're trying to replicate in robots so that they stop injuring people and we can actually take them out of controlled environments. So if you don't believe me, maybe you'll believe some other experts on the field who I'd like to quote briefly. So Yann LeCun, the chief AI scientist at Meta, recently said that humans can get smart with vision, even pretty smart without vision and audition, but not without touch. Remember that there are deaf-blind people in the world, but touch is a vital sense. And I'd like to also quote Rich Walker, who was at Codex 2022, so it's quite appropriate. He ended his talk saying that for robots to be useful in the real world, they are going to need to have a lot of human dexterity, but they're going to need to have even more of human touch. And I'm very happy he said this because he runs the company here in London that makes the most dexterous humanoid hands in the world for robots. So hopefully I've convinced you that the biggest barrier to mass robot adoption is their inability to feel the world around them at the moment. I founded Touchlab towards the end of my PhD to really change this. And my PhD was in electronic skin. So it's time for robots to come out of the lab and into the real world. So what is dexterity? Okay. So I'd rather just show you briefly what dexterity is instead of trying to explain it in words. This is an example of human hand dexterity, a very limited example, and a robot dexterously following what the human's trying to do. This is effectively what dexterity is. Can we transfer that from humans to robots? What we've done in Touchlab is make a quantum tunneling based electronic skin that's thinner than human skin. And that means that it can be retrofitted around the entire body of the robot from head to toe, including the fingertips, but not excluding the rest of the body. And it can be retrofitted onto existing robot fleets, meaning by adding it to existing robots, you make them into smarter robots. And I'd just like to show you a little bit where we started. So we started by trying to solve basically pick and place problems in a factory setting. This is a standard industrial gripper. What we've done is added our skin onto this robotique gripper and made it able to grasp a variety of objects that are delicate, for example, ripe strawberries and eggs in this case, but it can also do soft objects. Then we've moved on from there and started to look at humanoid hands. So you'll see a picture here of a human hand next to the robot hand that I just showed you. But this time, you'll see sensors on its fingertips and its palm. It's actually got 64 sensors on its palm, mapped to a human operator. And you can start doing new types of grasp with this retrofitting of electronic skin. And I'm going to show you something that I'm quite proud of that we did recently, without getting into too much detail. But we made one of the most advanced robot fingertips in the world, which covers 95% approximately of its surface area. It means it can sense, for example, right under the fingernail, on the sides of the fingers, even on curved regions. And this is going to allow robots to do a lot more than they currently can dexterously. And what's unique is that we actually calibrate the sensor for force ranges that are very similar to what humans can grasp. So for example, we can pick up very delicate light objects, but also heavy weights. We've made a fingertip that can do just that. And you can sense all these forces. In addition to that, we've tested in radioactive settings for hundreds of thousands of cycles. So it's really fit for mass production and industrial applications. We're going a little bit beyond that as well, and we're trying to mimic the human somatosensory system. So this is a piece of hardware, unique right now. But in addition to that, this forms the sort of skin element. And then we have our firmware and readout electronics that forms the nervous system of this. And then in addition, you have the robot brain that processes all this information. And what we're really focusing on right now is slip detection. We want to do the best slip detection in the world so that we don't have any of these factory burning down accidents when robots are handling goods and 0.1% of grasps fail, and then you have a problem. So in order to show that this is actually useful and that we can actually do new things with skin, what we then did is put a robot in a stroke ward. We tried to do a world first last year. We equipped an existing robot with our grippers and skin, and we went to Finland because they were willing to take that risk with us and had 5 months of active operation in the ward. We actually trained 14 nurses to teleoperate this nursing robot and made it for the first time safe to do so in an active stroke ward. Valku is a sort of a general purpose teleoperated humanoid robot, which basically means it's controlled by a nurse or a clinician in this case. Valku is operated using a haptic teleoperation setup. So you wear virtual reality glasses, you have a virtual reality controller and a haptic glove. You can control all the fingers individually, and you can feel touch from the fingertips and the palm. Thank you. So I'm just going to leave this in the background for now. What I wanted to say is that taking the robots out of the lab, out of a controlled environment, and going into a real hospital with people who, for example, stroke patients can't always walk properly, you have unpredictable environments, uncontrolled setting, you have just a huge amount of challenges we had to solve that were unknown unknowns for us. All the way from setting up our entire own network in the hospital to make sure that we didn't lose connection to the robot, no matter which room it was in. Some hospital walls are very, very thick. Some have extra shielding to prevent signals going through due to scanners and so on. But we actually managed to get all of this to work and transfer the sense of touch to nurse operators. So Here you can see an actual stroke patient that we interacted with. We had to blur their faces for ethical reasons, and we could only show you one. But we were able to push wheelchairs, interact with patients, make sure the robot gets into very tight rooms and corners, and does a few actually useful tasks. The one thing that most robot demos don't show you. Here you can see the controller interface. This is what the nurse sees. So, wrapping this up. I hope that was interesting. And I need to do some sort of bold prediction. Now, Rich Walker last time predicted that touch was going to be very important for robotics, so I can't say the same thing. What I want to kind of show you, this is the nurse interface, is that robots and humans will soon feel things we haven't felt before, thanks to electronic skin. This is a nascent industry right now. This is like computer vision in the early days. We're going to go through an exponential curve of miniaturization and increased performance in electronic skin soon. And what that means is that we'll very soon match human-level performance, most likely, in this domain, and maybe even exceed it. Like we can do now, we can put an infrared camera on a robot to give it night vision, which we did in the hospital. Soon we'll be able to do something similar with skin. Here you can see a nurse sitting in a chair. The nurse can feel, they have an electrostimulating suit so that they can feel when the robot is touched on different parts of the body. So they're feeling something slightly different already. And they have a haptic glove that pneumatically actuates 133 different points on the hand so that we can transfer that haptic sense of touch. But in the future, we might be able to do other things. We might be able to have prosthetics that give you a sort of spider sense. Some spiders can sense vibrations that we humans can't, so they can either catch prey or escape from other predators. We might even be able to have a skin that acts also as a microphone. Microphones actually sense the mechanical deformation of air. Once we add certain technologies, we'll be able to do the same with a whole skin around the robot body. So you might be able to one day, maybe with a neural interface or another device, teleport into a robot. It could be somewhere in space or subsea, or maybe just on the other side of the ocean to give a hug to a loved one. And you might be able to have a better sense of touch than you as a human have today. Thank you very much.
And